Hello and welcome back to Dr. Logic Awkwardly Does Logic with a cat because somebody asked me we need more videos with cats. So here is the best logician's cat ever. If she settles down, then we will talk about the rules for conditionals. Again, just as with the other connectives, there's one introduction rule and one elimination rule. The introduction rule is a little bit complicated, but since you've already seen the disjunction rule, the disjunction elimination in its full glory, I think you probably won't have too much problem with the introduction rule for conditionals. Let me bring up my whiteboard. I can balance it on one knee and pet a cat at the same time because these are the cool skills that logicians develop. So let's first look at the elimination rule for conditionals because that's actually the easiest. So this one says, whoop, there she goes. If you have a conditional and you have the antecedent, then you can write the consequent down on another line. So out in words, so if on line I, we have a well-formed formula phi implies psi, and on line J, we have the well-formed formula phi. Then on line N, where N is after both I and J, but note that the relative order of I and J doesn't matter. It doesn't matter if first you have the conditional and then you have its antecedent, or you have its antecedent and then you have its conditional. That doesn't matter. Whichever one you have, that's perfectly fine. So then on line N, you can write the consequent, which is psi, with annotation, conditional elimination, lines I and J. And the schematic form of the rule looks like this. At some point on line I, you have phi implies psi with some annotation, we don't know what. On line J, you have the antecedent again with some annotation, we don't know what. And if you've got both of that, then at some point later on, so long as you're in the same scope line, you can do psi. And this is conditional elimination, lines I and J. So if you're ever, when you're doing these proofs and you want to make sure that you have all of your rule applications correct, make sure each time that you double check that you are citing the correct number of things and the correct type of things. So our rules will always cite either lines or subproofs, and will always cite 1, 2, or 3 of those. So like conjunction elimination cites 1 line. Conditional elimination cites 2 lines. Disjunction elimination cites 1 line and 2 subproofs. Make sure you pay attention to these things, because if you get to a point where you're like, I need to cite 2 lines for conditional elimination, but I've only got 1, what do I do? The answer is, well, not conditional elimination, because you don't have what you need in order to be able to apply it. So let's see if I can actually write the conditional introduction rule and have some space. So the idea with the conditional introduction rule is that you start off, if you make some sort of assumption, doesn't matter what, you can assume whatever you want, whenever you want. But suppose you make this assumption, and from this you're able to prove certain things. Then that last thing in your little kind of internal subproof that you've done, this kind of mini conclusion, well, essentially what that entire subproof has done is said, well, if you give me what I've assumed, then I can derive you this conclusion. But that's just basically an if-then statement. That's a conditional. So conditional introduction takes one of these subproofs and turns it into a conditional that doesn't depend on that assumption. So there we go. This is conditional introduction. If we assume phi on a line I, so this is a new subproof, and from this assumption, I can prove Ooh, there goes my. What is going wrong with my tablet thingy? There we go. Well, I can randomly scribble, but I can also prove some formula psi on, say, line J. Then what I can do is I can terminate that scope line, so the one that I introduced at line I, and then write on line J plus 1 the conditional going from phi to psi, and the annotation is conditional introduction, and it cites the full subproofs, so the entire range from lines I to J. So schematically, what this would look like, we've got our proof going on, and then at line I make a new assumption. I do all sorts of interesting and fun things. And then at line J, I get this formula psi. Don't know what psi is, don't know what my justification for it is going to be, but it's just whatever I am able to derive from the assumption of phi at line I. Then what I can do is I can close off this subproof. I can say, okay, I'm done with that. I'm not going to use it anymore. I terminate the scope line and I discharge the assumption. So these are vocabulary words that you will hear me use when I'm working through actual proofs. So here on line J plus 1, I can then introduce the conditional. If phi, then psi, conditional introduction, citing the entire subproof. Now, the thing is, when you do these, once you've done a subproof, kind of what's in there isn't accessible anymore. So this is a little hypothetical proof that I've done, and when I'm done, I now have this conditional statement, but nothing that's between lines I and J can I actually access because they depended on an assumption that I can't rely on out here. Again, this will make more sense when we actually do some examples, but what I would like to do first is give you one more set of rules, and that will be the negation rules. They are both equally hard, but not as hard as disjunction elimination. And if you have an understanding of how the reductio ad absurdum rule worked, then actually negation introduction and negation elimination are going to seem very familiar. So that's what we have to look forward to next time. Hope to see you then. Cheers.